Where's Matt? Let's get this popcorn club meeting started.
Sorry I'm late. I had to finish this project so I could show it to you guys.
What does it do?
It's a magnetic linear accelerator. The Gauss rifle.
What a lovely device. It's named after Carl Friedrich Gauss, the French scientist who made up the math formula that helped explain the Gauss rifle experiment. Very impressive, Matt.
A rifle? Is it safe?
Oh man, I can't believe the mad scientist from Hillcrest Elementary wants to know if something is safe.
Of course it's safe.
Enough already. What is it? How does it work?
It works like when we play croquet at the class picnic.
You mean like when Kiki always won?
So tell us more, bro.
I always wondered why the ball that got hit with the croquet mallet never moved, and the one touching it always rolled away.
Yeah, how does that work?
Is it like the Newton's cradle?
Why, yes, Tori, it is. It's named after Sir Isaac Newton. As you all know, he was considered one of the most important scientists ever. He lived in England about 400 years ago, and he experimented and wrote about energy and motion. Tori, why don't you show us how it works?
Here goes. Look at the balls in the middle. Looks like they're just sitting there, doing nothing. Only the first and last balls move.
The steel balls that look like they aren't doing anything are actually busy transferring energy. When you pull the first ball back, you put energy into it. When you let the ball go, it hits the second ball, and that contact passes the energy from the first ball into the next one, touching it.
But you don't see anything.
That's right, Carson. You don't see energy. The only thing you could see is the action of the steel ball when the energy turns into motion. When the last ball moves, you get to see the release of energy when the ball swings outward. I think Matt's experiment will help us understand better.
When I release the steel ball, the magnet pulls the ball towards it. That's 1 unit of energy. The 1 unit of energy is transferred through the magnet and into all these balls. The next magnet pulls the ball towards it with 1 unit of energy, but the ball already has 1 unit of energy from the first magnet, so when the ball hits the second magnet, it has 2 units of energy, and the more energy it has, the faster it will go.
So each magnet pulls the steel ball even faster?
Even though we can't see the energy, we can see the action and motion that energy causes.
Here, this can explain it. The magnet pulls the ball towards it. When the ball hits the first magnet, the unit of energy from the magnet pulling the ball towards it moves through the magnet and into the second steel ball. The second ball looks like it is doing nothing, but it is actually passing all the energy into the next ball that is touching it. The third ball doesn't have anywhere to transfer the energy to, so it simply moves forward towards the next magnet that is also pulling on it with another unit of energy.
It is just like the Newton's cradle. These experiments make science fun.
I have another experiment that will help explain this idea.
What do we do with these?
Drop the ping pong ball and see how far it goes.
I'd say about 2 feet high.
Okay, Joe, it's your turn to bounce the golf ball.
The bounce was about 3 feet high.
Okay, Carson, place the ping pong ball on top of the golf ball and drop them together at the same time.
"32."
32?
Yeah.
I don't understand.
32 degrees Fahrenheit. It's the temperature in which water freezes. We say 32 if we like something or something is cool. When we do not like something or it is not cool, we say 212. That's the temperature where water boils.
I get it. That's way 32.
Okay, what exactly happened with the ping pong ball?
Matt, dear, click on the Newton's Law of Motion file, please. The golf ball is heavier, so it has more energy than the ping pong ball. When the golf ball touches the ground, all the energy in it must go somewhere. So that energy is passed back up into the ping pong ball that already has its own energy. The ping pong ball has nowhere to pass its energy, and the energy has collected from the golf ball. So it converts all the power into motion. It bounces higher when it is dropped with the golf ball than when it was dropped by itself, because it has the energy from the golf ball plus its own energy converted into upward motion.
I'm gonna try this experiment again.
Today's lesson was definitely 32, Miss B.